Hey, what's up guys, my name is Cherno. Welcome back to my game engine series. So last time we took a look at GLFW and sending events from GLFW into our event system. Definitely check out that video if you haven't already. And today we're going to be taking a look at something called a layer stack and essentially layers and what they are in a game engine, in our game engine, and how we're going to use them. And we're going to take a more practical approach to this. I'm just going to show you guys a bunch of code that I've already written that makes all that stuff kind of happen. And we might have a theory video sometime in the future. I don't think it's that necessary right now, at least, because it's quite a simple concept. I think you guys will get it once you see some code, and that might be a better way of explaining what it actually does. First of all, I want to give a huge thank you to all of the patrons that make this series possible. If you guys aren't supporting the series, you can do so by going over to patreon.com/thecherno. You'll get the code to a much more advanced version of Hazel already available to all of you guys, which has all of this stuff like way implemented, as well as all of these videos will kind of come out 1 week earlier for you guys as well. And it's just a really good way to help support this, because I do have a full-time job outside of this, and it's kind of hard for me to allocate time for this, but because of the support from the community, I'm able to actually spend a lot more time on this than I would have otherwise. So huge thank you to all of those people for making this possible. Okay, so layers. What are layers? Whenever I talk about layers to people, I usually end up comparing them to something like Photoshop, which isn't like a great comparison, I think, because obviously that's not as interactive as something like a game engine. But you can think of it as a layer in Photoshop, where you basically have an ordered list kind of layers, or a layer stack, as it's kind of called usually. And whenever you kind of want to draw something on the screen, layers determine what order things are drawn in. But the thing is, they don't just determine what order things are drawn in, and also layers aren't just applicable to graphics. Layers in a game engine they're also primarily applicable to events and also things like update logic, right? So we know that at the moment our game in the application class has a run function, which basically has a while loop that keeps kind of iterating over and over and over again until our game actually stops. That's called our game loop, right? So what actually will happen here is every layer that is inside that layer stack, which is currently kind of visible or currently enabled, right? Same way that you can kind of turn layers on and off in Photoshop and just hide them essentially, or disable them. You can do the same thing here as well. Whenever a layer kind of is enabled, then as we go through that game loop, each layer will be updated in the order that it actually appears in that layer stack as well, right? Through that kind of update loop, you can do rendering on that layer. And obviously, since the layer stack is ordered, that's very important, because it means that you can put layers on top of other layers, which will kind of determine draw order. And it's also very useful for things like overlays. In fact, it's even very useful for overlays to the point where I've actually built in like an overlay system into the layer stack, which enables you to kind of push, I guess, layers to the second half of the layer stack. So basically we have one contiguous list of layers, but kind of overlays are always at the end of that list, so that they get rendered last, which is very important, because if we decide that we want to, I don't know, render a gizmo or render some kind of debug graphics, which we want to have always on top of anything that we render, then we need to render it last. There's no real way about it. We need to basically disable depth testing and then render that thing last. That's how you get something to be on top of everything. So layers are kind of really important for that. But the other big thing with layers is events. Now, this is where it works the other way around, whereas we kind of have a list of layers and we go through them kind of in order from 0 to, size -1, essentially. We go through them in order. With events, we kind of go the other way, right? Because if you think about it, if I go and click my mouse on something, then the first layer that should receive that event is actually the last rendered layer. Because if we draw a button that is rendered on top of everything else and it's rendered last, that should be the first thing that receives the event. And then if that decides to handle the event, and it marks it as handled, then it does not need to get propagated further down the layer stack into the other layers, such as our 3D game world. Because obviously if we have a big button on the screen and we click it, we don't want our character to shoot his gun as well, for example, if this is like a first-person shooter game, because that has been handled by the thing that's on top, right? So we kind of have this kind of, going kind of forwards through the list and going backwards through the list. Forwards through the list to render it and to update it and do all of that kind of stuff. And then we go backwards in order to kind of handle events. And by backwards, I just mean we kind of start at the topmost layer and we work our way downwards instead of going from the bottom up like we would with rendering. That's pretty much it. So to sum up what a layer is quite an abstract concept. It's just what it is it's kind of like a section of your game that is kind of, or a section of your application that renders certain kind of things and also receives events, right? That sounds very vague, and when we get into it, it'll probably definitely make more sense. But if you think of it kind of practically, it might make more sense. So if you have like a 3D game world, let's just say we're making like a 3D game or whatever. We have our 3D game world, that sits on one layer. All of the 3D rendering gets done on that layer, that's kind of like our game layer. Any events that happen as well get kind of sent into that layer, and that is kind of almost, that layer is like the root to the rest of the game. It holds our scene, right? That's what it is. Everything kind of stems from that game layer. Then we might have like a debug layer or something on top of that, as like a game world debug layer. This is basically something that might only get pushed onto the layer stack in debug builds, and this will have maybe something like, I don't know, just some kind of debug graphics, some kind of, hitbox regions, or like things that, like cubes that get drawn, or red, like, cubes that get drawn on like certain characters because like when they get hit with a bullet, or like any kind of debug graphics that exists in our 3D world might be on that layer. And then we might have like a UI layer in our game, which is just a 2D kind of orthographical projection. That's another way that layers kind of tie in. Usually you would have one kind of projection for that layer. Obviously you can always switch projection and start rendering something else in a layer. That's also perfectly valid, but another good way to maybe imagine that division is if you just had like a UI layer, which has an orthographic projection, holds all of the UI to your game, that could be on a separate layer. And then, in fact, that would probably need to be on a separate layer, because when you click on a button, you would want it not to propagate down to the game layer, because that click event might do something else, and you want to essentially block that. And then on top of that, you might have like another debug graphics layer that's kind of for 2D graphics. That might be just like I am GUI or something like that, or some kind of menu items or buttons that you can click to trigger certain events that shouldn't be there in like debug builds or anything like that. Sorry, in release builds or distribution builds. But you might want to have it in like debug builds or release builds, kind of in-house release builds, so that you can kind of trigger certain events or load certain levels, just extra functionality essentially. So that could be a practical way of kind of looking at layers. All they are just kind of, I guess, groups of your application that receive events and usually render some kind of graphics. Okay, anyway, let's just jump in and start implementing this. I don't think there's not that much code, so I'll kind of walk you guys through it. And hopefully that in itself will kind of be enough. And we'll also create an example layer just to see how to use the API. Okay, so what I've done here is I've got Git diff tool up with Beyond Compare again, just to show you guys everything that I've done. But the first thing I'll do is I'll actually show you guys the new classes. So there's 4 new files, layerstack.h and cpp, and layer, h and cpp. We'll start with layer. This is, again, really simple. I don't want you to kind of picture this as like some complex thing. It can be used very powerfully, and we'll probably add stuff to it in the future, but for now it's really quite a simple implementation. Basically what we have right now is a layer which optionally takes in a name. If you don't provide a name, it just calls itself layer. This is more or less a debug name. Layers shouldn't really have names in distribution builds, because you shouldn't be addressing layers by names anyway, so this is kind of all for debug purposes. I'm not saying that like it would be that, bad for performance if you did have a name being stored per layer. But it's just again, you can see I haven't put macros around this to disable it in distribution builds. I'm just kind of making it clear that it's a debug name, so that you don't start using this stuff when trying to find layers or whatever, because you really shouldn't be doing that. We have onAttach, onDetach, onUpdate, and onEvent. So when a layer is attached, basically when a layer is pushed onto the layer stack and part of our application, we attach it. We can detach it as well when it gets removed there. That's basically like an on-init and on-shutdown type of thing. We have onUpdate, which gets called by the application when the layer is updated, which should happen every frame. And then we have onEvent, which is whenever an event gets sent to the layer, we receive it here. This is all virtual, so you can all kind of override this when you make your own layer. So the way that this is intended to be used is you basically subclass this class, and then you implement anything you want, and that's your layer. And then that when you do create a class that's like your game layer or something, and you do have all of this in it, you push it into the application, as you'll see in a minute, and it kind of gets put into that layer stack and thus gets updated and receives events and all of that kind of stuff happens. One thing I haven't put in here yet deliberately is the kind of enabling, disabling of layers. We'll do that a little bit further down the road because I don't want to complicate things too much. But basically, you would usually have either in the layer class itself a boolean which says whether or not it's enabled, and it allows you to disable the layer, which means that it will not be updated, thus it will not render, and also won't receive events. So it basically just kind of hides it from the layer stack. Or you could actually have that boolean being stored in the layer stack as well if you wanted to. Okay, the CPP side of this is really simple. We have an empty destructor. Obviously we need a virtual destructor because this is going to be subclassed. And then we just basically just store the name and that's it. So dead simple. Now the layer stack is a little bit more complicated than that, because what the layer stack is essentially a wrapper over this vector of layers. Now we're using a vector because every frame this will be iterated over. There will need to be a reverse iterator as well because we need to propagate events in a reverse fashion. But for things like updates, we always need to iterate through it. So there's no like real reason this should be like, oh, and also the reason it's not an actual stack is because we actually end up pushing things into the middle of it, as you'll see with overlays. But anyway, the idea is that we want some kind of contiguous data storage. I'm also just storing raw pointers here. No reason to really wrap this up in shared pointers or unique pointers or anything like that. It's really a dead simple kind of system here that is easy to handle. And in terms of ownership and all of that, layers are owned by the layer stack as soon as you give it to the layer stack. So when you push that pointer into the layer stack, you can see here, it pushes it into the right place. And then obviously when the layer stack gets destroyed, it gets deleted. Now, the other thing is when you pop layers, I should say the ownership here is a little bit interesting because when we pop layers, we don't lose them. It's only when the layer stack gets destroyed. Now, here's the thing. The layer stack is owned by the application, which means that basically the way this works is you can allocate your layer, and as long as you give it to the layer stack and don't take it out, it will be deallocated when the application shuts down. Okay, so layers are kind of intended to live throughout the lifetime of your application at this given point in time. In the future, of course, if you change levels or you do something like that, it might be worth recreating the entire layer stack. But again, in that sense, you would in fact recreate the entire layer stack, which means all the layers would get deleted via this destructor. Okay, so the ownership kind of tied, like during the duration of the layer stack, everything is tied to the layer stack. However, if you pop a layer temporarily, you can push it back in and you won't, like the layer will not be deleted. It'll just be removed from the, it'll be just removed from this actual vector, but it's not going to get deleted. So those are kind of the ownership semantics if you really care about that kind of stuff. Anyway, pushing layers and all that stuff is really simple. Layers get pushed into the first half of the list, as I said, and then overlays get pushed into the second half of the list is basically how it works. And there's some code around here to make that happen. The reason it's done that way is because overlays we always want to render last. If we push an overlay just at any point, we always want to ensure that it suddenly gets put into the very, very, very end, right? Whereas if we push a layer, it gets pushed before the overlays. So it'll get pushed as the last layer, but not kind of it will never be in front of overlays. Overlays will always be after layers. That's kind of why there's some code here to make sure that it gets pushed into certain places. For example, overlays you can see get pushed into the very back of the list, whereas layers get pushed into this kind of layer insert area, which also changes every time we remove or add a layer, right? So that kind of makes sure that layers get pushed into the first half of the list. Okay, so that is basically it. And then we have this implementation of begin and end so that we can use this in a range-based for loop as we'll do in the application class. So that's pretty much all there is to it. Again, what this layer stack is really just a wrapper around this kind of layers thing. I could probably type def this actual collection or using it just so that we wouldn't have to write it all the time here, but especially for the iterator, I guess, but I've made it a little bit more clear in this video at least. Maybe in the future it's something that we can change. Okay, cool. That's it. Those are the new files. Now let's take a look at the changes that have happened. So in ApplicationH, apart from sorting out these kind of includes, I've added two new functions, push layer and push overlay, which just take in that layer. As you can see, there's no way to kind of pop them yet, which is fine as well. This is supposed to be a simple kind of first step implementation. And then we also have a layer stack, which you can see is just created on the stack here, and thus kind of inherit the lifetime of this application class. Okay, that's pretty simple. Now, this is where it gets a little bit more exciting. So obviously this is very simple. We just push and this is just a wrapper essentially. We just push it to the layer stack as a layer or an overlay. But then we have on event and the run thing. Run thing, really simple, as you can see. We just iterate over all the layers in the layer stack. We can use that range-based for loop here because we implemented begin and end. And it just calls on update, really simple, kind of goes from the beginning to the end, includes overlays, obviously. And that's just what it does. And then here we kind of have to go backwards, right? So we go backwards through the layer stack, and we call on event whenever an event is received. If the event is marked as handled, we break, which means we do not continue. This also means that if an overlay handles an event, that's it, right? Layers will not get it, which is the intended behavior. Okay, that is it. Okay, so in hazel.h, which is our kind of public client-facing header file, I've just added layer.h here. Layer, of course, is included by application, so I didn't really need to do that because layer stack's included and all that. But I did that anyway, just to kind of be more clear, because layer is definitely something that should be accessible by the client. Now, in the Premake file, what I actually had to do was, this is kind of a bug that we had before. I basically set the build options to include the multi-threaded debug DLL and the multi-threaded DLL, right? Because what we had before, and this is for the runtime library, for the C++ runtime library, we were linking statically against this, which is an issue because since this Hazel thing builds a DLL, we ended up with kind of different heaps essentially for both the Sandbox and the Hazel and the Hazel project, because they were both getting statically linked into those respective projects. We can't have that because, and the way that I kind of found out about this was, I think spdlog, and it ended up trying to free some memory that was allocated by a different heap, and that crashed. Okay, so you need to make sure that if you are building a DLL, that you link against the actual DLL version of the runtime. I'll show you guys in Visual Studio. It's just under C++ code generation and then the runtime library. Okay, so I think by default it's set to multi-threaded debug like it is here. It should be multi-threaded debug DLL. Okay, so we need to link against the DLL version. And in Premake, if we do MDD like that, which I think is a switch. I mean, if you look over here, MDD, yeah, that's kind of the switch. Okay, so you can see that over here I've kind of done MDD, which enables that switch. Now, yes, it is controversial that it kind of shows up as multi-threaded debug here, but I don't know if there's an actual way to set it in Premake to not be that. Okay, so we kind of just include that, and then I'm not sure if it's Visual Studio's fault that it's not propagated here, but anyway, I'm not sure about that actually. That might be, if you guys know about this, because obviously it's kind of annoying that it shows up wrong here and then it gets overridden by the additional command line here. Maybe I've done something wrong, but it definitely seems to be linking the correct version of the library now. So we just did that to both Sandbox and to the Hazel project to make sure that we're linking the right runtime version of the right runtime library version, because again, we want the DLL, we don't want the static library. Okay, Sandbox app is where I did my example layer, which I'll show you guys in a minute. And then I think that's it. Okay, so not too many changes at all. So if we go to our Sandbox app, this is my example layer. So this is how you make a layer. And this is in the client, of course. So all you have to do is basically subclass this layer right into your own layer. You can give it a name if you want. And then I've just implemented on update and on event. Okay, two little functions here. In here, I'm just logging update, right? Because this should get updated every frame. And then of course on event, I'm just logging the event because we're not really doing anything with it yet. And then inside my Hazel application, which is Sandbox, all I have to do is push that layer. Okay, so I've just pushed that new example layer into that layer stack, and that's it. I could push it as an overlay, that would be totally fine as well, but I've just pushed it as a layer. And so if we run this little program of ours, one thing I want to point out quickly that I noticed in the output here, let me just dock this over here. So if we go to build, was that you can see that it's actually overriding that multi-threaded debug with this MDD option, which is the multi-threaded debug DLL. Okay. So it is in fact obviously linking the right version, but not great that it's having to override it, because it would be nice if it was set, and I'm not sure in Premake if you can do that directly. Anyway, so here we have this. I'll kind of leave this here, I guess. So you can see the layer is being updated all the time, and if I move my mouse or type some keys or whatever, it's receiving all of those events. And if I kind of just pause this, you can see Hazel's getting the event first, and then our app is actually getting the event. So this log is coming from our example layer. This log is coming from core, because if you look at the application thing, we actually have this hset core trace, which I can get rid of now, which traces kind of all the events that are actually received. Okay, cool. So that is that. We are going to very soon have a way more practical example of this, because our next step is actually going to be to add IMGUI to Hazel so that we can get some basic UI going, and we can start displaying stuff on the actual screen instead of in logs. So that's going to kind of be our next step. And of course, for that, what we will do is we'll create an IMGUI layer, which will handle all of the events that we need to propagate to IMGUI, as well as also handle all of the rendering. So that's kind of the future if you want to see where this is headed. And then obviously from there, once we start working on like the 3D renderer or the 2D renderer, we'll have a layer as well for kind of our 3D world or for our 2D world or whatever. So that is kind of where this is heading. Anyway, I hope you guys enjoyed this video. If you did, you can hit that like button. Layers are very important, and we're going to use this. They're kind of the basis for any kind of code that we really write, like in Hazel. Like if you look at the building blocks of kind of a game engine, which I might make a video soon about now that we're kind of a little bit more clear on the architecture of Hazel. We're kind of going to review kind of how that works, but we basically, client side, we create an application and we create a layer. And then that's kind of it. The application is kind of the core runtime and the game loop and all that stuff of our thing. And then layer is actually the stuff that renders and receives events. And thus it's kind of the thing that we both see, the user kind of sees in the form of rendering and also interacts with in the form of events. So it's kind of a really base building block of kind of the core engine, and something that obviously we're going to use a lot in the future. If you want to support the series, patreon.com/Cherno. Huge thank you as always. I don't need to keep telling you guys that this series really wouldn't be here without you guys. So I really am thankful, because it's amazing how like a nice core section of the community can be so generous as to help support this series, and then the rest of you guys kind of get to see it for free. So I really am thankful to those guys, and that's why they receive rewards such as all of the code behind the scenes of Hazel and all of the stuff that I've written in my spare time, as well as videos 1 week early. In fact, the next video, in which we probably will start implementing IMGUI, is already up for patrons. So yeah, hope you guys enjoyed this video. Thank you for watching, and I'll see you next time. Goodbye.